Okay, this one is a quite easy problem. Coulomb's law in vector form. So this is related to Coulomb's law in vector form. So if you remember, we have derived in the class expression for Coulomb's law, that is the expression for force, in terms of vector form. So if you write in a scalar, so force is given by Q1 Q2 divided by 4 pi epsilon naught r square. So this is in the vector form. The same equation can be written in terms of, this is in a scalar form. In vector form, this equation can be written as F is equals to Q1 Q2 by 4 pi epsilon naught r q. R is the magnitude, and then I will have a vector r, and this vector r is along the line joining the two charges. So vector r is along the line joining the two charges. Are you getting or not? So now let me read the question. This question says a positive point charge of 50 microcoulomb is located in the plane at the point whose radius vector is this r0. So let us say, so this is my xy plane. I have this side x-axis and this side y-axis, and one charge is located at point 2i plus 3j. So let us say I have a coordinate here. This coordinate is 2i plus 3j. So 2, 3 is the coordinate for this point. And the magnitude of charge is 50 microcoulomb. So Q is given to you. Q is 50 microcoulomb. Now the question says, find out the electric field at a point whose radius vector is given at I minus 5j. So now I have a point somewhere here, and the radius vector of this point is at I minus 5j. So x is positive, y is negative, so that is at I minus 5j. Now I want to find what is the electric field at this point. So now of course one can expect that electric field due to this is along the line joining these two vectors, so this to this. So electric field will be in this direction. So this is the direction of electric field. Now what is this vector? So this vector you can always find. So let us say this vector is vector r1, this is vector r2. So let us call this a vector r1, and let us call this a vector r2, and let us call this a vector r. Now I can apply the triangle. In the triangle I will have this plus this should be equal to this, because triangle I can apply. So vector r1 plus vector r, this is equal to vector r2. So this means vector r is nothing but vector r2 minus vector r1. Now r2 and r1 is given to you. So r2 is this vector, that is at I minus 5j. So let us plug this value. R2 is at I minus 5j minus r1. R1 is what? 2i plus 3j. So that is 2i plus 3j. So this will be, so 8 minus 2, 6i minus 5 minus 3 minus 8j. Now things are very simple. Magnitude of r, that will be r. So this is simply a square of 6 plus a square of 8 under root. So this is 10. So now electric field, you see from the top I can write Q by 4 pi epsilon naught. So the force is Q1 Q2. We have to find electric field. So electric field is Q by 4 pi epsilon naught r square and into, let us say, rq and vector r. So this is the electric field. Now Q is 50 microcoulomb, and this is 1 by 4 pi epsilon 9 into 10 power 9. So this is 9 into 10 to the power 9 into Q is 50 microcoulomb. So 50 into 10 to the power minus 3. This divided by RQ, R is 10Q, and multiplied by this vector, that is 6I minus 8Z. So this multiplied by, I can write here 6I, I can write on the next page or here itself 6I minus 8Z. So let us write, so this into 6I minus 8Z. Charge is microcoulomb, so I have to write 50 into 10 to the power minus 6. This is not millicoulomb. 50 into 10 to the power minus 6. Now do your own calculation. So if you are doing calculation, you will find, so this is 10 to the power 3 cancels out, so I will have 10 to the power 3 and 10 to the power minus 6, so 10 to the power minus 9 goes, so we will have 50 into 9 into 6I minus 8Z. I think we are not able to see this one. So this is 450 into 6I minus 8Z. Are you getting or not? Or if you want, you can take two common. So 900 into 3I minus 4Z. So this is the direction of electric field as well as magnitude. Both will be given by this expression. So in the vector form, electric field is given by this expression. Now if somebody asks what is the magnitude of this electric field and what is the direction of this electric field, so magnitude of electric field will can found using 900 into magnitude of 3I minus 4Z. So let me write, so magnitude of 3I minus 4Z is 5. So 3a square minus plus 4 square root, so this is 5. So 900 into 5, so this will be 45, so 4.5 into 10 to the power 3. Are you getting it? So this will be the magnitude of electric field. You can put the unit also, kilovolt, so volt per meter. Now if somebody asks what is the angle the electric field makes with the x-axis, so I have by component, I have x component, so tan alpha, where alpha is the angle that is made by the x-axis. So this is my x component, this is my y component, and this is my angle alpha. So that is E vector with x and E vector with y. Ex and Ey makes an angle alpha with x, so I can write tan alpha is E by Ex, and Ey is minus 4 and Ex is 3. So this is the angle that is made by the electric field vector with the x-axis. That is alpha is tan inverse minus 4 by 3. So this problem is quite easy problem. So this is tan inverse minus 4 by 3. So you see, in this problem what we have done is we have simply written the Coulomb's law in vector form, and then I have proceeded to find vectors and take the magnitude to find the total electric field strength, that is the magnitude wise, and to find out the angle alpha, that the electric field resultant electric field will make with the x-axis, that is the E by Ex. So that will give the alpha. So alpha is the angle that is the resultant electric field makes with the x-axis. We'll discuss the next problem.